In the fourth lecture, we are going to talk about electrical energy, and we can also think about it in terms of batteries and all, because battery, those they store energy in the form of chemical energy. Ultimately, we are going to get the electrical energy out of it. Okay? So we do have a slight overlap of the topics as such. Okay. The electrical energy storage technology can make it easier to deploy renewables on a large scale by providing electricity when renewables can't. So what happens is, as we have some and looked into it a number of times, that a backup power supply is very important. But this time what we do is we try to store the electrical energy, because sometimes if the renewable doesn't work, if you are having a dam and you are generating hydroelectricity, and if you also have some stored electricity, the stress on that hydroelectricity also lessens. Okay, so that is important. Now, wind power basically produces electricity only where wind is blowing. So we have specific conditions for this. For solar power, we definitely need the sun to be shining most of the times. Okay, there also in certain locations, because of the region or the location or the angle at which the sunshine falls and all, we cannot generate electricity out of solar power for 24 hours. Okay, so that means it makes it harder to match the electricity supply with the demand. So the demand might be there, but still the generation might not be there from these renewable power sources. So that's why storage is important. So if you consider something like a traditional base load, mostly in India we do use coal as a power source, and the nuclear power plants are also used. Okay, but not in India, of course, more in abroad. We know that. And of course, other dispatchable sources, like let's say the natural gas, it basically can be scheduled to produce power in specific amounts at specific times. So there is some kind of restriction that we have. It can actually produce power, no doubt, but the kilowatt hour or the megawatt hour that is being produced is restricted, and it cannot be produced 24 hours. There is certain time during which it can be produced. Okay. So, what are the benefits of storage? So, usually if you store energy in the form of electrical, chemical, mechanical energy and so on, they can actually defer the new generation and transmission investment. By that we mean that if we want to upgrade a system, it takes a lot of time. Definitely it needs a lot of finance, new ideas, new plans, optimization of the system and so on. So right now, if we are not in a situation to do that, we can store the electricity and definitely defer this new generation power system, and of course the transmission investment. Okay, if we can store it, we can definitely improve the grid quality. So basically what happens is, every now and then there is power cut. So these things can be avoided because they can be combined with the conventional power sources, and definitely because of that we also have something which we call the stability at a lower cost. So even we can actually supply a base voltage which is always stable. The voltage fluctuations can be much lesser. Well, compared to olden days, nowadays the fluctuation is much lesser because the technology has updated, but definitely we need more and more provisions for doing that. Okay, there is something which is called the ancillary services. Basically these are the services which deals with stabilizing and increasing the reliability of electricity grid. Okay, so that we can actually have an efficient power supply. So these additional things are basically called nothing but the ancillary services. These ancillary services are there, and then if we can actually do the setup in a proper way, and storage will definitely help us during extreme weather events. So if there is something like, let's say it's a cloudy weather for a number of days and you are not able to generate solar power, definitely this storage is going to help. So the extreme weather condition can also be handled. Sometimes the battery doesn't work because of the cold temperature condition, as we have seen in the lead acid battery. Now that can also be tackled using a power source system which can actually store electric power. So the use of electrical energy storage is basically limited to the rate of storage in other energy markets, okay, such as the natural gas or the petroleum, where reservoir storage and tanks are used. So if you want to store something else, like let's say the natural gas or the petroleum, which is one of the indirect sources of generating the electric source, okay, electric power, it's basically the amount that you can store is much higher compared to the energy of electric power that can be actually stored. So the global capacity of this is a simple data here. The global capacity for electricity storage as of September 2017 was 176 gigawatts, and that is actually just less than 2% of the world's electric power production capacity. So we definitely want this to go up, because we want to store more and more electricity possible. And this storage facility also is not available everywhere. Most of the developed countries have them, okay, but developing or the underdeveloped countries still lags in that, okay. So we need a lot of finance for developing such system. Those issues are always there. So what are the basic technical options based on which actually we can store the electrical power? Well, the first option is pump hydro. I'm going to discuss some of them in the later slides. It's something to do with the hydroelectricity, but here we are basically storing it by using a source which can actually produce lesser electricity, okay. Definitely rechargeable battery, as we have seen in our last lecture, storing the chemical energy. That is also a source to store electric power. There is one more storage system which is called the compressed air energy storage. These are actually used in the power plants to move the turbine, okay. Then we have got the thermal energy storage. We have already read about it. We must have heard about hydrogen fuel cells and hydrogen fueled gas turbines. So fuel cell is also a form, but if fuel cell is still in the developing stages, it can definitely generate a lot of clean energy, but at the same time research is still going on to make it efficient so that it can be incorporated into a traditional power system. And then we have got something which we call as the flywheel. These terms you must have heard about. This is also something like a turbine which keeps on rotating, okay, and then it basically generates the power. Capacitors we have studied about supercapacitor. There is also something which is called the ultra capacitor. So basically it can store a lot of electrical energy, but then these supercapacitors and ultra capacitors cannot store it for a long time, as we know. If we consider something like a supercapacitor, these can be used in lifts and all to actually give a sudden burst of energy or burst of electric power, so that some temporary work can be done, okay. So this is basically working on a different mechanism altogether, so it cannot store it for a very long period. And then we have got the superconducting magnetic energy storage. So here basically a magnetic source is used to actually store the electric power, and depending on the need, the magnetic field can be removed so that the electric power can be released. So these are some of the very simple technological options for storing electric power. Let's just have a look at some of them to understand it better. So the first topic is the pump hydro, okay. So what happens is in a pump hydro storage, it basically uses low cost electricity which is generated during the periods of low demand to pump water from a lower level reservoir. So we don't need much of mm, finance for designing such system. It is basically low cost and electricity, and if the demand is low, this pump water can be actually used to form a lower level reservoir. So basically it can be generated from there. Basically I can have a lake, okay, which basically stores water, and that water actually can be used to generate the electricity. Or we can actually also have some storage of water in a higher elevated region where that can also be used at the same time. So it is something like a hydroelectric power, but the only thing is here we are storing the energy. So what happens is, if there are periods of high electricity demand and the prices are higher, basically water is released to the lower reservoir while turning the turbine to generate electricity similar to conventional hydropower. So we can use a lower level source, okay, and then actually turn the turbine actually to generate the power. So this pumped hydro storage is appropriate for load leveling, okay, and it can be constructed at large capacities of 100 to 1000 megawatts. So it can be constructed at large capacities, and we can actually have up to 1000 megawatt energy, and then we can actually store it and discharge it for a longer period of time, let's say 7 to 13 hours. So you can keep on discharging that much of energy at specific intervals or at a specific rate for, let's say, up to 7 to 13 hours. So use of this technology is actually limited by the availability of suitable geographic location. So in case you want to use the water which is stored in a lake, you need to have a lake over there. So obviously you need to have some restrictions in the geographic locations that we can use. Next is called rechargeable battery. We actually have learned a lot about rechargeable battery, and there are several types of large scale rechargeable batteries that can be used for electric storage. Sodium sulfur, we have a partial idea of these, the lithium ion batteries and the flow batteries. So I guess the flow batteries we have already stated in the last lecture, but basically what happens is not like traditional battery. Flow batteries basically uses a fuel that is external to the battery, that is not within the battery, and there are basically chambers in which these fuels are stored. Okay, so what happens is the fuel flows through the battery to generate electricity through an electrochemical process. Okay, so these are all there, and we have a lot of fuel there. Okay, so we can actually generate more and more electricity. And since the fuel flows and because of which the battery generates electricity, these are actually nothing but called the flow batteries. So what happens is battery can be used for both power quality. So in case you are using a laptop or the mobile that you are holding right now, okay, you basically have a constant power supply. So basically the power quality is there, it doesn't deteriorate, there is no fluctuations. Okay, and at the same time there is load leveling, so that is also very important, no fluctuations. So it's a very important part of battery design. In addition, when electric vehicles became more widespread, okay, so the electric vehicles is right now scarce, it's not much in number, but if they become widespread, these batteries will definitely be used for the energy storage. Okay, we need to store energy for a longer period of time, the mAh or the capacity should be more, and so on. So in some cases definitely they will provide the load leveling, and if there is any kind of energy fluctuation or energy arbitrage, services by recharging when demand is low provide electricity during peak demand. So basically we can recharge the system where we need the electricity when the demand is low. When the demand is low, we need to supply less electricity to the grid, so the remaining electricity can be used to power the battery or charge the battery and keep it in stock. And when the demand is high, we can actually release that electricity from the battery. Okay. So the lithium ion batteries basically have the highest installed capacity, but as we all know that the lithium ion batteries are mostly used in rechargeable in devices which uses rechargeable battery. But if we want to implement it with a power grid or a power plant, then it becomes a bit difficult. But still, lithium ion batteries is used widely, and this is basically followed by the sodium sulfur and lead acid batteries. Okay, we're not really concentrating on power plants here, we're just concentrating on storing electric power. Okay, so we can basically use that is being used, but obviously on not a very wide scale. So this is interesting. Okay, during my course of preparing this lecture, I also came across this for the first time. This is basically called the compressed air energy storage. So if you basically have an air compressed, then you basically open it through a very small opening, air comes bursting out, right? So basically there is a huge pressure difference that is being created. So this pressure can be actually used to move the turbines. Okay, so let's just read through this. So this is basically a hybrid generation storage technology in which electricity is used to inject air at high pressure into the underground geologic formation. So basically you have got some kind of location where you actually use electricity to inject air into a underground system. Okay, now this is basically not specific everywhere, we need some geologic formation, so it is again restricted by the geographical region that you are in. So basically what happens is when the demand for electricity is high, the high pressure air is released from underground, and this basically helps to power the natural gas fired turbines. So this electricity is released from the underground, and you basically have a turbine which is connected to a power plant, or might be a hydro power plant, and so on. Okay, so if you basically have a power plant, we know that in a Rankine cycle or whatever we have studied, we have seen the turbine is the most important part. Turbine rotates basically connected to an alternator, or okay, and which generates the electricity. So rotation of turbine is important. So what happens is this, the pressurized air that we have allows the turbine to generate electricity using significantly less natural gas. So this compressed air energy storage is also appropriated for load leveling. Okay, that can also be done because we can control the pressure at which the air is getting released, and basically it can be constructed in capacities of few hundred megawatt. So basically the output that it gives is also quite high, so that helps in the load leveling purposes, and it discharges over a very long period. So these are some of the very good advantages of these kind of system. So if we look into the storage technology capital cost, okay, it's in dollars, okay, per kilowatt hour. this might fluctuate because we do have a lot of issues here, okay, depending on the location and so on, okay, in the country in which you are basically doing the construction. If you basically consider a compressed air system per kilowatt hour, well, kilowatt hour is not a very high capacity if you consider a power plant, but still it's how it is measured. We have got 116 to $140. We basically consider a pumped hydro system, it is 152 to $198. And as we go below, we see that if we are basically using a sodium battery, the price is very high. A lithium ion battery also has got a very high price, okay. So basically lithium ion battery definitely is used, widely used, but if you want to set it up on a larger scale, the cost definitely goes high. But this compressed air, as we see, is relatively cheaper, it's much cheaper, but the issue here is that this is actually restricted by geographical locations, okay. So this is very important. So this is an article in this Lizard, okay, you can just type in and you can check, okay, this is there. So it's the information is available, okay. So before we end, I'll just like to talk a bit about superconducting magnetic energy storage, which is called SMES. So this stores energy in the magnetic field created by the flow of direct current in a superconducting coil. So we know that superconductors are certain materials which actually has zero resistance, at least theoretically, okay, and in some devices even practically also we have zero resistance, but it is not possible at a temperature like room temperature and so on. We must have a temperature below the room temperature, much lower, okay. So basically we need to have a system, a cryogenic system, which basically cools the temperature so that this material behaves in a superconducting way, okay. So that means the superconductors the temperature is cooled down, the material behaves as superconductor, and the energy is stored in the magnetic field, okay, which is being created by the flow of direct current in this superconducting coil. So if you consider a typical SMES setup, it basically has three parts. The first part is a superconducting coil. The second part is a power conditioning system. So that is the additional thing that we need for the simple reason that you need to cool down the material to become a superconductor, because the critical temperature is such that below it will be a superconductor, above it will basically nothing but a normal metal. So this has to be used cryogenically cooled refrigerator. So we need a lot of setup there. So once basically the superconducting coil is charged, okay, the current will not decay and the magnetic energy can be stored indefinitely. So basically you have the coil which stores the magnetic field, okay, and this energy can be used. How do we use it? If we discharge the coil, okay, it will basically be used, released back into the network to be used, okay. So this is what is a superconducting overview of basic superconducting magnetic energy storage is, okay. So that's all for today. See you in the next class. Thank you.